Let's start with aldehyde ketones and carboxylic acid. So let's read from the book. Carbonyl compounds are of utmost importance to organic chemistry. They are constituents of fabric, flavorings, plastics, and drugs. In the previous unit, we have studied organic compounds with functional group containing carbon-oxygen single bond. In this unit, we will study about the organic compounds containing carbon-oxygen double bond, means C double bond O group. This group is called as carbonyl group, which is one of the most important functional group in organic chemistry. In aldehyde, carbonyl group is bonded to carbon and hydrogen, while in ketone it is bonded to two carbon atoms. So let's try to understand what is the difference between aldehyde and ketone. So here this is carbon and it is bonded to oxygen by a double bond. And these are the two valencies of carbon. So this is carbonyl group. This group is carbonyl group. In aldehyde. So now let's try to understand what is aldehyde. In aldehyde, this carbonyl group. This is carbonyl group. To one side it is bonded to one of the carbon and on the other side it is bonded to hydrogen. So when this carbonyl is bonded to carbon and hydrogen, it is called as aldehyde, or this group is called as aldehyde functional group. Now come to the ketone. So this is ketone. In ketone, carbonyl group, this is carbonyl group and it is bonded to both sides to the carbon. Then it is called as ketone. This is ketone functional group. Now let's read from the book. The carbonyl compound in which carbon of the carbonyl group is bonded to carbon or hydrogen and oxygen of hydroxyl moieties are known as carboxylic acid. So what is the carboxylic acid? So let's draw the structure of carboxylic acid. So this is carboxylic acid. In carboxylic acid, this is carbonyl group and to the one side it is bonded to H or it may be bonded to carbon. On the other side it is bonded to OH group. Then it is called as carboxylic acid group. Means the group C double bond O and it is bonded to OH. This group is carboxylic acid group. Now let's read from the book. While in the compounds where carbon is attached to carbon or hydrogen and nitrogen of NH2 moieties are to halogen are called amides and acyl halides respectively. So what is amides and what is acyl halide? So let's draw the structure of amide. So what are amide? So this is the carbonyl carbon in which carbon is bonded to oxygen by a double bond. And here to one side it is bonded to R group or you can say carbon and on the other side when it is bonded to NH2 group. This group is called as amide group. C double bond O NH2. This group is called as amide group. Now come to the acyl group. Acyl halide. So this is acyl halide. So this is carbonyl carbon. So this is C double bond O C. This is carbonyl group. To one side it is bonded to one of the alkyl group and on the other side it is bonded to one of the halogen. So this group C double bond O X group, this is called as acyl halide group. Now let's read from the book. Esters and anhydrides are the derivatives of carboxylic acid. The general formula of these class of compounds are given below. So here, when you see here C double bond O H, this group is aldehyde group. In ketone, C double bond O group is there where carbonyl carbon is bonded to two R groups, means two alkyl groups are bonded to carbonyl carbon. In carboxylic acid, Carbonyl carbon, on the one side it is bonded to OH group, then it is called as carboxylic acid group. In acyl halide, carbonyl carbon is bonded to halogen. In amide, this carbonyl carbon is bonded to NH2, then it is called as amide. In ester, when this carbonyl carbon is bonded to alkoxy group, it is called as an ester. In acid anhydride, so let's try to understand how anhydrides are formed. So let's draw the structure of carboxylic acid. So this is C double bond O and it is bonded to one of the OH and the other side it is bonded to R group. Similarly, draw the another molecule C double bond O. To one side it is bonded to OH and on the other side it is bonded to R group. So when you remove water molecule from two acid molecule, so here H2O, we have to remove H2O from carboxylic acid. So when you remove this water molecule from carboxylic acid minus H2O, you will get the structure C double bond O. It is bonded to O. When it is joined with C double bond O, this side is R group, this side is another R group. So this is called as acid anhydride. Aldehydes, ketones and carboxylic acids are widespread in the plant and animal kingdom. They played an important role in biochemical process of life. They add fragrance and flavors to the nature. For example, vanillin from vanilla beans, salicylaldehyde from the meadow sweets and the cinnamon aldehyde from the cinnamon have very pleasant fragrance. This is the structure of vanillin in which aldehyde group is there. This is the aldehyde group, this is alcohol group and this is ether group is present. In salicylaldehyde, this is aldehyde group and here this is hydroxy group is there. In cinnamon aldehyde, this is aldehyde group which is bonded to vinyl carbon. They are used in many food products, pharmaceuticals to add flavors. Some of these families are manufactured for the use as solvent. For example, acetone. Acetone is one of the ketone. And for the preparing materials like adhesive, paints, resins, perfumes, plastics and fabrics, etc. Now we are going to learn the nomenclature and structure of carbonyl groups. Now come to the nomenclature and structure of carbonyl groups. Aldehyde and ketones. Aldehyde and ketones are the simplest and most important carbonyl compounds. There are two systems of nomenclature of aldehyde and ketones. First system is the common name system. Aldehyde and ketones are often called by their common names instead of IUPAC names. The common name of most aldehydes are derived from the common name of the corresponding carboxylic acid by replacing the ending "ic" of acid with aldehyde. At the same time, the name reflects the Latin or Greek term of the original source of acid or aldehyde. The location of the substituent in the carbon chain is indicated by Greek letters alpha, beta, gamma, delta, etc. The alpha carbon being the one directly linked to the aldehyde group, beta carbon next, and so on. In the first structure, this is acetaldehyde. The formula of acetaldehyde is CH3CHO. As it contains CHO group, this is aldehyde. Next is the benzaldehyde. As the aldehyde group directly bonded to the benzene ring, the name of this molecule is benzaldehyde. In the third structure, there is aldehyde functional group and the carbon next to functional group is the alpha carbon and the carbon next to alpha carbon is the beta carbon and carbon next to beta is gamma carbon. As here bromo substituent is bonded to beta carbon, the name of this molecule is beta bromo butyraldehyde. The common name of ketones are derived by the naming two alkyl group or aryl group bonded to carbonyl group. The location of substituents are indicated by Greek letters alpha alpha dash, beta beta dash, and so on. Beginning with the carbon atom next to the carbonyl group indicated as alpha alpha dash. Some ketones have historical common names. The simplest dimethyl ketone is called as acetone. Acyl phenyl ketones are usually named by adding the name of acyl group as the prefix to the word phenone. For example, here, common name of dimethyl ketone is acetone, and this is phenyl alkyl ketone. For alkyl phenyl ketone, they usually name by adding the name of acyl group as prefix to phenone. So here this is phenone and prefix is aceto group. As it contains 2 carbon, for 2 carbon the prefix is aceto. In the third example here, 1, 2, 3. So phenone for benzyl group and propiophenone as it contains 3 carbon, including the carbonyl group. So the name of this molecule will be propiophenone. In another example, here there are 2 benzene rings. So the name of this molecule will be benzophenone. Now come to the IUPAC name. The IUPAC name of open chain aliphatic aldehyde and ketones are derived from the name of corresponding alkane. While in common name system, the name is derived from the name of corresponding carboxylic acid. But here in IUPAC name, the name of aliphatic aldehyde or ketone is derived from the name of corresponding alkanes by replacing the ending E with al for aldehyde and on for ketone respectively. In case of aldehyde, the longest carbon chain is numbered starting from the carbon of aldehyde group. So this is the important thing that you have to remember. In the case of aldehyde, the longest carbon chain is numbered starting from the carbon of the aldehyde group. While in case of ketones, the numbering begins from the end nearer to the carbonyl group. The substituents are prefixed in alphabetic order along with numerals indicating their position in the carbon chain. The same applies to the cyclic ketone, where the carbonyl carbon is numbered 1. For cyclic ketones, carbonyl carbon is numbered 1. When the aldehyde group is attached to a ring. When aldehyde group is attached to a ring, suffix carbaldehyde is added after full name of cycloalkane. The numbering of ring carbon atom starts from the carbon atom attached to the aldehyde group. The name of the simplest aromatic aldehyde carrying the aldehyde group on benzene ring is benzene carbaldehyde. However, the common name benzaldehyde is also accepted by IUPAC. Other aromatic aldehydes are hence named as the substituted benzaldehyde. So let's try to name the following compounds. In the first example, here C double bond O H is there, means it is an aldehyde. Now count the number of carbons present in this molecule, including the carbonyl carbon. So here this is 1 and this is 2. So there are 2 carbons present in this molecule. So the parent name will be ethane. This time you have to replace this E with al. So the name of this molecule will be ethanol. In the second example, here again the functional group is aldehyde. So first of all count the number of carbons including this carbonyl carbon. So it is 1, 2, 3, 4, 5, 6 and 7 carbons are there. So the parent alkane will be heptane. As in contain aldehyde group, you have to replace this E with al. So replace this E with al. So the name of this parent will be heptanol. Now there are substituent. This is one substituent, methyl substituent, and this is one bromo substituent is there. So methyl is bonded to third carbon and bromo is bonded to fourth carbon. But when you write the substituent, you have to arrange them in alphabetic order. So first we will write bromo, then we will write methyl. So the complete name of this molecule will be 4-bromo 3-methyl heptanol. Now come to the third example. In this third example, first of all identify the functional group. Here functional group is C double bond O, means the functional group is ketone. So this is ketone. This is cyclic alkane to which ketone is bonded. So first of all count the number of carbons starting from the carbonyl carbon. So this is 1, 2, 3, 4 and 5. So as it contains 5 carbon, the name of parent alkane will be cyclopentane. And as it is a ketone, you have to replace E with ONE. So the parent name will be cyclopentanone. Now there is methyl substituent bonded to third carbon. So the complete name of this molecule will be 3-methyl cyclopentanone. Now come to the next example. First of all identify the functional group. So here CHO group is there, means this is an aldehyde. Aldehyde bonded to cyclic alkane. For that you have to use carbaldehyde. Now count the number of carbon. So as it contains 6 carbon, parent alkane will be cyclohexane. And as it contains aldehyde group, you have to write cyclohexane carbaldehyde. Now come to the second example. Now come to the next example. Here again functional group is aldehyde. And there is another functional group. Double bond, means alkene is also there. First of all number the chain. 1, 2, 3, 4 and 5. So the parent is pent. And double bond is at second position and you have to replace E of pentane with ul. So the name, so here you will write pent 2-ene ul. Now come to the next example. First of all identify the functional group. So functional group is ketone. So this is ketone functional group. To one side of this ketone, phenyl group is there. So this group is called as phenyl group, means the benzene with one free valency is this phenyl group. And on the other side, 1, 2, 3. 3 carbon ketone is there. So the name will be propane as it contains 3 carbon. And as this is a ketone, you have to write ONE. So in this parent chain, ketone group is present at first position. That's why we will write 1-one. And this phenyl group is also bonded to one position. So that's why. And this phenyl group is also bonded to first carbon. So the name of this molecule will be 1-phenyl propane 1-one. Now come to the next example. Here, first of all identify the functional group. This is one functional group which is ketone and there is another functional group is aldehyde. So there are two functional groups in the same molecule when ketone and aldehyde both are present. So when ketone and aldehyde both are present in the same molecule, aldehyde will get priority over ketone. Means this time you have to use prefix for ketone and suffix for aldehyde. Here we are going to use suffix al for aldehyde and prefix for ketone, it is oxo. First of all count the parent carbon chain. First of all count the carbons in the parent chain. And whenever we start numbering, you have to start it from the aldehyde carbon. So this is 1, 2, 3, 4 and 5. So parent is 5 carbon long. So the name of parent will be pentane. And you have to replace E with ul as we are using suffix for aldehyde. So the parent name will be pentanol. And ketone group is present at third carbon. So here we will use prefix for ketone. It is oxo. So we will write 3-oxopentanol. Now come to the next example. Here functional group is again ketone. Now number the chain. So we will number it from either direction because in both the case ketone will get the same number. So 1, 2, 3, 4 and 5. At second position methyl group is there. At fourth position again methyl group is there and ketone is bonded to third carbon. And ketone is present at third position. So the name of this molecule will be 2,4-dimethyl pentane 3-one. 2,4 because two methyl groups are bonded at second at fourth carbon and ketone is present at third position. Now come to the next example. Here, this is the benzene ring and aldehyde functional group is bonded to benzene ring. In the IUPAC name also, benzene, it is considered as benzaldehyde. Here aldehyde group is bonded to benzene ring, means this is benzaldehyde. And benzaldehyde is a common name but it is also accepted in IUPAC system. So you can simply write benzaldehyde for this molecule and find out the position for NO2 nitro group. So when you number this benzene ring, you have to number from the carbon to which aldehyde group is bonded. So this is first, second, third and this is fourth position. So nitro group is present at fourth position of benzaldehyde. So the name of this molecule will be 4-nitro-benzaldehyde. Other name you can write 4-nitro-benzene carbaldehyde. Both the names are correct. Now come to the next example. Now here identify the functional group. So there are 1, 2 and 3 aldehyde groups are there. You have to give same preference to all the aldehyde groups. So first of all number the chain. So this is 1, 2 and 3. So aldehyde group is present at 1, 2 and 3 carbon. It is bonded to 1, 2 and as well as 3 carbon. So here you have to write the parent name, you have to write propane and there are 3 aldehyde group bonded to first, second and third carbon. You have to write propane 1, 2, 3 tricarbaldehyde. Though we use carbaldehyde for the cyclic aldehyde only. Though we use carbaldehyde for the cyclic aldehyde only. But here to give the preference, but to give the equal treatment to all the aldehyde group, here you have to use carbaldehyde. The common and IUPAC name of some aldehyde and ketones are given in table 8.1. So HCHO. Here how many carbons are there? First of all identify the functional group. CHO means aldehyde functional group is there and as there is just one carbon, the name of this molecule will be methanol. The common name of methanol is formaldehyde. In the second example, CH3CHO. So again, CHO means aldehyde group is there and there are 2 carbons. As there are 2 carbons, the name of this molecule will be ethanol. And the common name is acetaldehyde. So both the common names are very important. You have to remember acetaldehyde and formaldehyde. Because in most of the reaction we are using this common name. Now, again there is CHO group in third example. Now draw the structure of this molecule. So let's draw the structure of this molecule. So this is CH3, single bond C, again CH3, H, C, double bond O, H. Now select the longest carbon chain, including the aldehyde functional group. So this is the longest carbon chain which includes your functional group aldehyde. Now number this chain, starting from the aldehydic carbon. So this is 1, this is 2 and this is 3. So substituent methyl is bonded to second carbon. So the name of this molecule will be 2-methyl propane instead of E you have to use Al, propanol. So the name of this molecule will be 2-methyl propanol. Now come to the next example. Here again CHO group is there, means this is aldehyde. Now start numbering from this molecule. Now start numbering from the carbon to which aldehyde is bonded. So it is 1, 2 and 3. Means methyl is bonded to third carbon and aldehyde is bonded to first carbon. So there is no need to mention that number of aldehyde group. So the name of this molecule will be 3-methyl cyclohexane carbaldehyde, or the common name of this molecule is gamma methyl cyclohexane carbaldehyde. Why it is gamma? Now let's assign alpha, beta and gamma notation to the carbons. So the carbon to which aldehyde group is bonded, this first carbon is alpha carbon, second carbon is beta carbon and third carbon is the gamma carbon. So methyl group is bonded to gamma position. So that's why the name of this molecule is gamma methyl cyclohexane carbaldehyde. Now come to the next example. Here CH3CH OCH3 CHO. So let's draw the structure of this molecule. So this is CH3 CH, here is O, CH3, single bond CHO. So first of all identify the functional group. CHO means this is aldehyde functional group. So this is aldehyde. Now identify the substituent. So here OCH3. OCH3 is methoxy functional. OCH3 is methoxy substituent. Methoxy substituent. Now number the chain starting from the aldehyde. 1, 2 and this is 3. So the name of this molecule will be 2-methoxy. Parent is 3 carbon long. So the name of parent will be alkane. And here you have to replace E with al. So here you will write propanol. Next CH3, CH2, 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 CHO. Count the number of carbon. There are 5 carbons and aldehyde group is there. So the name of this molecule will be pentanol. Next CH2 double bond CH-CHO. So in this molecule, when you start numbering from aldehyde, 1, 2 and this is 3. So double bond is present at second position. So the name of this molecule will be prop-2-enol. Prop-2-enol. Now come to the next example. Here there are 2 aldehyde groups bonded to benzene ring. So the name of this molecule will be benzene 1,2-dicarbaldehyde. In the next example, Here functional group is aldehyde and bromine is the substituent. So when you start numbering from the carbon to which aldehyde is bonded is the first carbon, this is second, and this is third carbon to which bromine is bonded. So the name of this molecule will be 3-bromo-benzaldehyde, or you can write 3-bromo-benzene carbaldehyde. Now come to the ketones. So here functional group is CO. CO is ketone functional group. You have to number this molecule in such a way that ketone gets the lowest possible number. So first of all, let's draw the structure of this molecule. So let's draw the structure of this molecule. So it is CH3, C double bond O, CH2, CH2 and CH3. So when you number this chain, you will number it from left to right. So 1, 2, 3, 4 and 5. So it is 5 carbon long. So the parent name will be pentane and ketone is present at second position. So the name of this molecule will be pentane 2-one. Now come to the next structure. CH3 whole twice, CH, CO, CH, CH3 whole twice. So let's draw the structure of this molecule. This is CH3, single bond CH, again CH3 is there, C, double bond O, single bond CH, single bond CH3 and here again CH. Now select the longest carbon chain that contains functional group ketone. So this is the longest carbon chain that contains functional group ketone. Now number this chain. So when you number it, 1, 2, 3, 4 and 5. So methyl substituents are bonded to second carbon and fourth carbon. So when you write the name, you will write 2,4-dimethyl pentane 3-one. Now come to the next example. Here there is cyclohexane and ketone functional group is there and there is one methyl substituent. So starting from the carbon to which ketone is bonded. So this is first, second. So when you name the molecule, you will write 2-methyl cyclohexanone. Now come to the next example. Let's draw the structure of this compound. So this is CH3 carbon, again CH3, there is double bond CH, single bond C, double bond O and this is CH3. Now select the longest carbon chain. So this is the longest carbon chain that contains your functional group ketone. Now number the chain. So we will start numbering from here 1, 2, 3, 4 and this is 5. There is methyl substituent and which is bonded to fourth carbon. This methyl is bonded to fourth carbon. Double bond starts from 3. So the name of this molecule will be 4-methyl pent 3-ene 2-one. In the next video, we will learn about the structure of carbonyl group.